Hi, today we're going to look at section 6.5, which is on properties of logarithms. Before we do that, though, I want to look at a simple example, and that is how do you multiply this number times this number? Now, that's 1,000 times 10,000. But, normally when you do this, what you would say is, let's see, we've got 3 zeros here and 4 zeros here. So the answer is going to be 1 followed by 7 zeros. Did I get that right? Let's see, 1 followed by 1, 2, 3, 4, 5, 6, 7. Yeah. So the answer here is we add the zeros, or add the number of zeros. And really, when we do this, we're using logarithms. Because what's going on here is, let me erase this. You've got 3 zeros here, 4 zeros there. When we multiply it together, we get 7 zeros. Well, if you look at it, these numbers here in purple, 3, 4, and 7, those are the base 10 logs of those numbers above. And that's an example of using what's called the product rule for logs. Here it is. Log base b of m plus log base b of n is equal to log base b of mn. So in other words, logs convert multiplication to addition and addition to multiplication. There are two important things, though, for this rule. One is you have to have the same base on both logs. And in order to add them together, your coefficient in front of these logs has to be a 1 in both places. If it's not a 1, you have to somehow get rid of it, and we'll see how to do that in a few minutes. So let's use the product rule to expand some of these things. So this one here, log base 2 of 8x, we've got a product inside of here, so I can rewrite this as log base 2 of 8 plus log base 2 of x. And I can evaluate log base 2 of 8, because that says 2 raised to what power gives you 8, and answer is 3. So we get 3 plus log base 2 of x. All right, this next one, log of 3x squared. You can rewrite this as log of 3 plus log of x squared. And another thing you might notice is if you've got log of x squared, you can break that up as multiplication as well. So we could rewrite this as log of 3 plus log of x plus log of x. And if you want to do something further, you've got 2 log of x's, so you can put them together here and get 2 log x. Really, the only part of this, or well, the main thing here is splitting it into this. You might notice that this 2 came down front eventually, and we'll see later that's the power rule. That's two more rules later. So let's do this last one. Natural log of this, that's natural log of x plus natural log of 2 minus x. All right, and one more. This would be natural log of x squared plus natural log of e to the x. And of course, natural log of e to the x, we can rewrite that since we have a base e log and a base e exponential. This is just natural log of x squared plus x. All right, so logs convert addition to multiplication. They also convert subtraction to division. And that's where the quotient rule comes in. The quotient rule says log base b of m minus log base b of n is equal to log base b of m over n. And again, the exponents, or not exponents, the coefficients of both of these have to be 1, and the bases have to be the same in order to use the quotient rule. So a similar thing to what we did before. When you divide, if you divide this number by this number, what we do is, we cancel the zeros out. So we're left with 1,000. Well, this is really the same as subtracting logs. The log of this number on top is 1, 2, 3, 4, 5. The log of this number is 2. And so 5 minus 2 gives you 3. What that is, 3 is the log of this number, 5 is the log of this number, and 2 is the log of that number. All right, so let's use this rule to combine some things into a single log. So if you've got natural log of this minus natural log of that, you can put this together into natural log of the quotient x squared plus 2 over x plus 5. All right, this next one is sort of interesting. It's got 3 logs. Now, what I can do is first, I can group them however I want. I could group them like this, or I could group them like this. Doesn't matter. We'll do this one. So this turns it into log of 3 plus log of, that's going to be 101 over 17. And now I've got 2 logs added together, so I can change this into, using the addition multiplication rule, get log of 3 times 101 over 17. Of course, I could make that as log of 303 over 17. All right. Now this last one I've got a star next to because this one has something we've got to deal with first. It's got this 2 in front. So we can't just plow straight into this one. We've got to deal with the 2 first. Now, what I'm going to do here is I'm going to do this the long way. I'm going to split this into log 7 plus log 7 minus log 4. And now I'm going to put these together. This becomes log of, let's see, 7 times 7 minus log 4. And so now I've got a difference of 2 logs, so it's going to be 49 over 4. And again, we could have done this by taking the 2 and moving it up top, because it winds up becoming an exponent instead of a coefficient because of the product rule. Well, not the product rule, the product rule. Because we split it up like this, we've got 2 log 7s, so we multiply 7 together twice, and we get 7 squared. All right, but let's look at the product rule, or the power rule, I'm sorry. The power rule says this: if you've got a coefficient in front of log base b of n, you can take that coefficient and make it into a exponent. I tend to think of this as hopping upstairs, or if you're going the other direction, hopping downstairs. So let's eliminate these coefficients. 5 natural log of x, that's natural log of x to the 5th. All right, number 2 here, 3 natural log of 2x, that's 3 natural log of 2x. Well, no point in recopying that. The 3 moves up top, so this is natural log of 8x cubed. All right, similarly, this is going to be log of x squared to the 7th, so that's log of x to the 49th. Or not 49th, 2 times 7 is 14. Power to a power we multiply. And then down here, this will become log of 2 to the 9th, and 2 to the 9th is 512. All right, so that's pretty much all there is to using the power rule. The only thing is you have to be sure to distribute the exponent to everything. Like over here, be sure it gets on the 2x. So here's a question for you. True or false? Log of 4x squared is equal to 2 log 4x. So what it's doing is hopping this 2 down front. What do you think? This is false. because if you have a log of 4x squared, you can't pull that 2 down front because it's the 2 only applies to the x. So we could split this up if we wanted to. We could take log of 4x squared. One thing we could do is we could split it into log of 4 plus log of x squared, and then get log of 4 plus 2 log x. So notice this is not what we get. We get log of 4 plus 2 log x. Now another thing we could do, we could take log of 4x squared. We could rewrite the 4x squared as log of 2x quantity squared. And then bring that 2 down front. We get 2 log 2 plus 2 log x. And notice these are the same things, because 2 log 2 here, if we bring the 2 down front, or wait, we can't bring the 2 down front. We could bring this 2 up here. If we did that, then we would have log of 4 plus 2 log x. Now, which way would I want to see it? It doesn't matter. This and this, they're both perfectly fine ways of writing this. All right, so what we've done here is some condensing and expanding. We condensed like 3 logs into, 2 and 3 logs into a single log. And that's what we're going to look at in the next video, is more stuff on condensing and expanding logs.